In this section, we're going to look at solving trigonometric equations where we may have to make substitutions using our trigonometric identities to be able to solve. Let's take the equation, the square root of 3 secant theta equals 2. Well, if we solve this for secant, the secant of theta equals 2 over the square root of 3. And we could figure out what secant was, but what would be a lot easier is to take the reciprocal of secant, which is cosine, and take the reciprocal of 2 over the square root of 3, which is 3 over the square root of 2. Now we want all the values for theta, where theta is between 0 degrees and 360 degrees. So we think, what angle has a cosine of square root of 3 over 2? And since it's positive and it's a cosine, we know we'll be in quadrants 1 and 4. So that would be 30 degrees would be our reference angle. So in the first quadrant, it's 30 degrees. In the fourth quadrant, it would be 330 degrees. And we're able to solve for this. If we look at another one, four sine theta minus 2 cosecant theta equals 0. Okay, we've got two different functions. We need to have just one function to be able to solve unless we could factor out a common function, which we don't have here. So we know that cosecant is 1 over sine. So this would be the reciprocal of, this would be 2 over sine theta equals 0. Now we have two options here. One would be to get a common denominator and then set our numerator equal to 0. Another thing that we learned back in algebra was that we could multiply both sides of the equation by the common denominator, provided that we eliminated any value that would make the denominator 0. Well, if we want to see what would make the denominator 0, then we set the sign equal to 0, and we know that our angle, theta, then would have to be either 0 degrees or 180 degrees. It's on the x-axis that the sine of an angle is 0. So as long as we eliminate 0 and 180 from our solutions, then we could go through and multiply both sides of our equation by sine theta. So we'll multiply, I'll go ahead and distribute it. This would give us 4 sine squared theta. Here my sines cancel, so minus 2, 0 times sine theta is 0. And now I have an equation with just one function, so I can solve it. I'll add 2 to both sides. Divide both sides by 4. So that would be 1/2. Now, to solve and by taking the square root, so the sine of theta would equal plus or minus the square root of 1/2, which is plus or minus 1 over the square root of 2, or the square root of 2 over 2, if we rationalize it. So what we want are the angles where the sine is equal to square root of 2 over 2. Since it's plus or minus, that means we're in all 4 quadrants. So the angle whose sine is square root of 2 over 2 is 45 degrees. And as I said, we're in all 4 quadrants. So in the first quadrant, it would be 45 degrees. The second quadrant, it would be 135. In the third quadrant, it would be 180 plus 45. So that would be 225. And in the fourth quadrant, 360 minus 45 would be 315 degrees. So that gives us all the values of theta that would make this equation true. So we had to do a reciprocal. And then we had to remember that if we're going to multiply through an equation by the common denominator, we have to eliminate those values from our solution set. Okay, let's take this one. We've got 2 sine theta plus sine of 2 theta. Now, we can't solve this one as it is. We've got the same function, but we don't have the same angles. So we're going to have to do some changing, and we have an identity for the sine of 2 theta. So we're going to substitute in for the sine of 2 theta, which is 2 sine theta cosine theta equals 0. Now, we still have two different functions. We have a sine and a cosine, but notice we can factor out that common one. We can factor out a 2, and we can factor out a sine theta. So this would be times 1. 2 sine theta times 1 is 2 sine theta plus cosine theta. And now each factor only has one function. So we set each factor equal to 0. So we know the sine of theta equals 0. Well, the angle that has a sine of 0 is 0 degrees and 180 degrees. It's the x-axis. We would subtract 1. So we want to know, well, when is the cosine negative 1? And that's at 180 degrees on the x-axis. So one of those values repeated, but that means that our values would be 0 and 180. Now we can also do this giving our answer in radians. If we had the cosine of 2x minus cosine x minus 2 equals 0. Now we want to give our answer here in radians. So you look at the domain that you're given, and our domain is in radians, so we want our answer in radians. Well, again, we have two different angles. We have 2x and we have x. So we're going to substitute in for the cosine of 2x. And we know that for the cosine of 2x, we have three different identities. Cosine squared x minus sine squared x, 2 cosine squared x minus 1, and 1 minus 2 sine squared x. Well, since my other term is cosine, I'm going to use the 2 cosine squared x minus 1 minus cosine x minus 2 equals 0. Combining my like terms, I have 2 cosine squared x minus cosine x minus 3 equals 0. And now I can either use the quadratic formula, or I could factor, and I always like to factor. Since I have a coefficient, this is where I do that a times c. So 2 times 3 is 6. It's a negative 6. So I want numbers that multiply to be negative 6 and subtract to be negative 1. Well, my choices are 1 and 6, 2 and 3. So these are the two that multiply to be negative 6, or 6, and they subtract to be 1. And since it's a negative 1, this would need to be a negative 3 and a positive 2. So I can put 2 cosine squared x plus 2 cosine x minus 3 cosine x minus 3. Remember, I just replaced that negative cosine x with 2x minus 3 cosine x. We can factor out then a 2 cosine x. 2 cosine x times cosine x. 2 cosine x times 1 minus I can factor out a -1. -1 times, or excuse me, I can factor out a -3. That'll be a lot better. -3 times cosine x, -3 times +1 is -3. So I have a common factor of cosine x plus 1 times 2 cosine x minus 3 equals 0. Setting each factor equal to 0, cosine x plus 1 equals 0, and 2 cosine x minus 3 equals 0. So cosine x equals -1, and that would be 180 or pi. We know that the cosine of 0 is +1, so when we go to the negative side of our x-axis, it's -1. Now here we would add 3 and divide by 2. We get 3/2. Well, there's no value for x where the cosine would be 3/2. Remember, it always has to be between -1 and +1. So there's no solution there. So our only answer for this one would be that x equals pi. Let's take this one. 4 sine squared x plus 4 cosine x minus 5 equals 0. And we're going to give these answers in radians also. Now, we've got two different functions. We have a sine squared and we have a cosine. So we need to think what we can replace one with. And we have a Pythagorean identity where we can change sine squared in terms of cosine. We don't have any identity where we can change cosine to sine. So I'm going to replace my sine squared with 1 minus cosine squared plus 4 cosine x minus 5. Now if I distribute, I have 4 minus 4 cosine squared x plus 4 cosine x minus 5 equals 0. And combining, I'm going to put these in descending order, so that would be -4 cosine squared x plus 4 cosine x minus 1 equals 0. Well, again, I have a quadratic. So it's possible, I can always use the quadratic formula, but it's possible to be able to factor this. It's difficult to factor with that negative here, so we're going to factor out a -1, which leaves us 4 cosine squared x minus 4 cosine x plus 1. And again, I'd need to multiply. 4 times 1 is 4. Factors of 4 that add to be 4 would be 2 and 2. Now what you might remember from algebra is that when those factors turned out to be the same, this was a binomial squared. So we would ask what squared's 4 cosine squared? Well, that would be 2 cosine x minus, and then 1 squared is 1. So if you remembered that, you can go, it's going to be a binomial squared. If not, then you would say, well, that's going to be 2x, 2 cosine x, 2 cosine x. And then you've got your 4 cosine squared x. These signs will both be negative. Your plus 1, and then you would factor by grouping. So you could factor out a 2 cosine x and factor out -1, and you would get your answer. But that's a short way of remembering it. When those factors turn out to be the same numbers, it means it's a binomial squared. Now we know that -1 doesn't equal 0, so we don't have to consider it. But 2 cosine x minus 1 could equal 0, so 2 cosine x equals 1. The cosine of x equals 1/2. So we want to know what angle has a cosine of 1/2. Now, since it's positive, we're in the first and the fourth. Well, that's 60, which is pi over 3. We wanted these in radians. So it would be pi over 3. Or this would be 2, which would be 6/3. Minus 1/3 would be 5 pi over 3. Okay. Let's take as our problem the sine of theta minus square root of 3 cosine theta equals 1. Now, this one's a little bit harder because I've got a sine, I have a cosine, but I don't have any identity that I can replace one of those with to make the other. And I have two different functions. So we're going to do a technique here of we will get one of these by itself. And so it would be easiest to get the sine by itself. So we'll have sine theta equals 1 minus square root of 3 cosine theta, 1 plus, excuse me. So I added 3 cosine theta to both sides. And then what we're going to do is we're going to square both sides. Now, one thing we'll have to remember at the end is in algebra we learned that when our technique was to square both sides, we always had to check for extraneous solutions. Sometimes we introduced an extra solution. Because when you square a positive number, like if you square 2, you get 4, but if you square negative 2, you also get 4. And so we sometimes get those extra solutions. So what this is going to give us then is the sine squared theta. Now this one you would need to multiply 1 minus square root of 3 cosine theta times 1 minus the square root of 3 cosine theta. So that gives us 1 minus the square root of 3 cosine theta, then minus square root of 3 cosine theta, plus, okay, square root of 3 times the square root of 3 is 3 cosine squared theta. So we end up with 1 minus 2 square roots of 3 cosine theta plus 3 cosine squared theta. And that's starting to look a little bit more complicated, but we can now substitute in for sine squared. Sine squared is 1 minus cosine squared. And now everything's in terms of cosine. So we want to get this equal to 0, so we're going to subtract 1, and we're going to add cosine squared. And I'm just going to do that all in the same step. So this would leave us with 0. 1 minus 1 is 0, so we have negative 2 square roots of 3 cosine theta plus 4 cosine squared theta. And this one's an easy one to factor because they both have a cosine theta. So we could factor out and I'm not sure why I changed my plus to a minus. So this should have been a plus and a plus. And this is a plus. So what I can do is I could factor out a 2 square root of 3. I could factor out a 2 cosine theta. So here I would be left with square root of 3 plus 2 cosine theta equals 0. Setting each factor equal to 0, 2 cosine theta equals 0, and square root of 3 plus 2 cosine theta equals 0. So we know it's not the 2, so cosine theta equals 0, and cosine equals 0 at 90, and we're going to do these in degrees. So cosine is 0 at 90 degrees and at 270 degrees. Here we would subtract the square root of 3. And divide by 2. So the cosine's the square root of 3 over 2 at 30, and it's negative, so that means we're in the second or the third quadrant. So we get that theta would be 150 degrees, or theta would be 210 degrees. Now we have to check these solutions because we did this little thing up here of squaring both sides. And you can check your solution by using a calculator, or we can just substitute in. And I'm going to make just a little room over here, and we can substitute in. These are not too hard to do. 90. The sine of 90 is 1 minus the square root of 3. The cosine of 90 is 0. So 1 minus 0 is 1. So 90 checks out. If we do 270, the sine of 270 is negative 1. The cosine of 270 is still 0, and negative 1 minus 0 does not equal 1. So the 270 doesn't check out, so we'll have to get rid of it. Okay, 150. Reference angle's 30. We've already talked about that. So the sine of 150 is 1/2. We're in the second quadrant. It's positive. Minus the square root of 3 times. Okay, the cosine of 150 would be square root of 3 over 2, and we're in the second quadrant, so it's negative. So we have 1/2 plus, okay, square root of 3 times the square root of 3 is 3 over 2, which gives us 4 over 2, or 2. Well, that doesn't equal 1. So 150 doesn't work. Okay, for 210, reference angle's 30. So the sine of 30 is 1/2, but 210 is in the third quadrant, so it would be negative 1/2 minus the square root of 3. The cosine of 30, or 210, is square root of 3 over 2, but we're in the third quadrant, so it's negative. So we have negative 1/2 plus 3/2, which is 2/2, or 1. So it checks out. So because we squared both sides, then we had to check our solutions. But the reason we did that is because this was just in terms of sine or cosine, and we could not substitute in for one of them. So the only way we could substitute in was by getting one of them squared. So we got one side by itself, and then we squared both sides, and we were then able to solve. Okay, let's look at this one. The sine of theta over 2 minus the cosine of theta equals 0. Well, here again, we don't have the same functions and we don't have the same angle. So we're going to have to change them. And we know that we could change sine to the square root plus or minus 1 minus the cosine of theta over 2 and minus the cosine of theta equals 0. Well, again, I have a radical. I'm going to go ahead and put that plus or minus. So I need to get my radical term alone. And now I can square both sides. To get rid of a radical, we square both sides. Now when you square a plus or minus, you get just the positive. If it's positive and you square it, it's positive. If it's negative and you square it, it's positive. So it's going to be positive what's under the radical, 1 minus the cosine of theta over 2 equals cosine squared. And we can multiply both sides by 2, so we would have 1 minus cosine theta equals 2 cosine squared theta. And we're going to have a quadratic, so we can add cosine and subtract 1. 2 cosine squared theta plus cosine theta minus 1. And then we can factor that, or we could use the quadratic formula on it. This one is factorable, but we haven't used the quadratic formula lately, so let's do that. So it would be that the cosine of theta is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So negative 1 plus or minus the square root of 1 plus 8 over 4, which is negative 1 plus or minus the square root of 9 over 4, which is 3. So if it's the plus, negative 1 plus 3 over 4 would be 2 over 4, or 1/2. Negative 1 minus 3 would be negative 4 over 4, or negative 1. So now we're going to go back and we're going to say, okay, the cosine of theta equals 1/2, or the cosine of theta equals negative 1. Well, the angle that has a cosine of 1/2 is 60. In the first quadrant, it's 300 in the fourth quadrant, and the angle that has a cosine of negative 1 is 180. Now, we did this by squaring both sides. If you remember way back up here, I squared both sides. So we're going to have to check, and we always check it in the original. So let me go ahead and rewrite the original down here where we can see our angles. We had the sine of theta over 2 minus the cosine of theta equaled 0. So for 60, that would be the sine of 60 over 2 minus the cosine of 60. Well, 60 divided by 2 is 30. The sine of 30 is 1/2. The sine of 60 is 1/2. That gives us 0. So 60 checks out. The sine of half of 300 would be the sine of 150 minus the cosine of 300. Well, here your reference angle's 30 in the second quadrant, so the sine of 150 is 1/2. Reference angle is 60 in the fourth quadrant, so that would be 1/2, and we get 0. So that checks out. Now for 180, that would be the sine, half of 180 is 90, minus the cosine of 180. So that would be 1 minus a negative 1, which ends up being 2. So this one doesn't work. So we have to eliminate that. Now, in the other lesson that we had on solving equations, we talked about you can check them with your calculator, and we can solve these and check them by using our calculator also. It's a nice little thing to do. So let's just take this one and check it with our calculator. Now, since we did our answers in degrees, and we got, we got 60 and 300 for our answers. So let's do this one in degrees. If you had your answers in radians, then you would do that. So let's make sure we're in the degree mode. Now what we do, we've got a choice here. And let me show you both ways. One way we can enter it and find the zeros. We can say the sine of x divided by 2 minus the cosine of x, and let's check our window. We really only need it from 0 to 360 because that's all that we gave our answers for. And that's probably good. Let's graph it and see if that gives us all that we need. Well, let's go back. Since we're looking for our zeros, we probably really need to have it go back into the negatives. So let's go down to maybe -1 because we need to see all the places where it crosses the x-axis. Okay, now what we do is we do second calculate, and we're wanting our zeros here because we let it equal 0. So we move it to where we're crossing the x-axis. Enter, enter, enter. Whoops, I did that incorrectly. So let me go back. I was doing the intersection one. So second calculate the 0. It says left bound. We want to move our cursor to where it's to the left of where we cross. Then we move our cursor to the right of where we cross. And then we can guess. And that gives us our 60 degrees that we came up with. Do second calculate number 2. We move it to the other one. We want it to be to the left. So enter, move it to the right, enter, enter, and that gives us our 300. Now the other way that we could have done this to check it is we could have solved one side. So we could have said, well, the sine of pi over 2 equals, of theta over 2 equals the cosine. We could have had the sine of theta over 2 equals the cosine of theta. And what we would do there is we would go in for y sub 1, we would just put the sine of, we'd put the left-hand side. So we're going to delete this part. And then for y sub 2, we would put the right-hand side, the cosine of theta. And we would graph these. And what we're wanting now are these points where they intersect. So now we can do second calculate, and we're wanting number 5 where they intersect. And here's where you just have to put it on top of each other. So we do the enter, enter, enter. And that gives us our 60. And second calculate number 5. We move our cursor to the other point of intersection. Enter, enter, enter. And we get the 300. So you can check these using your calculator. And again, if you solved it and it was in the radian mode, then you can put your calculator in the radian mode and do the same thing. But it gives us a way of solving. So in these problems, we looked at some other techniques. In some of them, we had to do substitutions. change using our identities. You may have had a half angle or a double angle and you had to substitute in your identity for that. We had a few problems where we had to square both sides and to get it to a point that we could substitute. And remember that when we do square both sides, uh, then you want to make sure that you check your answers because we could get extraneous solutions.